Hello everybody, my name is Sari. I work as a researcher in the University of Lapland, Rovaniemi, Finland, and I would so wish to be there in France with all of you. It's not the same talking to this laptop, but anyway, I'm looking forward to hearing all of your presentations, and I hope that you will find your way into mine. So I will talk you about Centennial legacies of historical reindeer herding on tundra ecosystem processes. And first I explain you something about the background. So I'm mainly a soil ecologist that who is analyzing soil processes, meaning organic matter decomposition that releases the carbon dioxide into atmosphere and eventually determines the carbon storage in the ecosystem, and also nitrogen cycle. So when microorganisms decompose organic matter, they also mineralize this nutrients into the forms that plants can take the nutrients up again. And then when you think about it, soils are governed by the past to a very large extent because it's formed by our past vegetation. So naturally understanding how past events have modified today's ecosystems is necessary to predict the future, because the soils also create the conditions under which our vegetation today and tomorrow are growing in. So in this topic, the approach of historical ecology is ever more important. But then talking about that, how can ungulates impact soil carbon and nutrient cycles? So I will explain the route to this. So grazers, they select some plant species over others, which in a way creates a competitive advantage to those plant species that they are not eating. And they are also trampling the soil, and some plant species are more sensitive to trampling than others, and kind of those then benefit that are not sensitive to trampling. And they also fertilize the soil because they transform the plant biomass into nitrogen-rich waste products. And all of these factors together influence plant species composition that in turn determines the quality of plant litter, meaning that how easily degradable all these organic compounds in the plant litter are for soil microbes. And that when this plant litter accumulates in the soil, it forms the long-term soil organic carbon stock. And all these soil processes, they release carbon dioxide into the atmosphere, kind of it's the carbon cycle, and they also release the nutrients, and then the indirect impact of soil nitrogen mineralization is also influencing vegetation and plant productivity. So this is the cycle then that what ungulates generally do in ecosystems. And the most common way to study the effect of grazing is to exclude them from the system. So here is one example from tundra in Kilpisjärvi. And when you think about it, it's like there have been herbivores for the past 10,000 years here, and in a way that you kind of you study then the effect of grazing through excluding them and seeing that what in time what happens if you don't have any herbivores, and usually you do find differences in nitrogen mineralization and all soil processes, and they are often very complex, so you can have opposite effects in different kind of system and different areas depending on which mechanisms there are most dominant. And also we have utilized this pasture rotation fences. So here is one example from northern Norway. So it's then separating a lightly grazed area and a heavily grazed area, and this heavily grazed area experiences high reindeer density during the time when reindeer migrate from the summer ranges to winter ranges. And these studies have demonstrated one interesting phenomenon. So after this vegetation transition, it's actually that you see a difference in soil microbial processes, but it becomes insensitive of the actual grazing event. So you actually see this timing of reindeer migration, so when the reindeer are actually there, and you see a difference in microbial nitrogen and microbial respiration, but it's not bigger in that time that the reindeer are there. So it induces ecosystem change into another state, and after that everything is going on differently than before. So that then raises a question that if there are if this is kind of the effect of grazing becomes insensitive to the actual grazing event, so what kind of legacies do this reindeer herding that happened in the past still have the current ecosystem? And could we use these legacies to predict long-term consequences of the current ecosystem changes? So if we study a system that has where ecosystem change has occurred a long time ago, then maybe we know then that what happens to those systems in the long term that are changing currently. And these questions were approached using historical milking grounds in northern Sweden. And these sites were formed by a form of reindeer herding that is no longer happening. So during this time period, the reindeer were very tame, and they traveled with Sami reindeer herders across the tundra during summer, and they were gathered every evening for milking, and that's why we call them milking grounds. And the Sami stayed at one camping site for about 2 weeks until they moved to the next one. And and here you see this this chain of different milking grounds that you can identify from the landscape. And these sites still differ in vegetation with clear borders to the surrounding tundra, even though they haven't been used for about 1 century. So it clearly demonstrates a legacy of past reindeer herding on vegetation. And in this study, we separated them into 2 different vegetation types. One was a tundra heath, and the other was a shrub tundra. And comparison of old and current aerial photographs demonstrate that they are slowly shrinking, but they are still surprisingly stable. And then what I have had to explain to reviewers quite comprehensively is that how do you know that this vegetation is not naturally herb and graminoid dominated? So there are several lines of evidence. So firstly, we know that similar vegetation transition have taken place with contemporary reindeer grazing with these pasture rotation fences, and also we find graminoid and herb vegetation under conditions that should be heath or shrub vegetation. It means that they are high ridges and they have low soil pH. So generally, if you have graminoid dominated vegetation in tundra, it's not in these kind of locations or conditions. And also that there are historical records describing how reindeer herders lived. And it's describing that what was their lifestyle and how they moved, how long did they stay in one place. And also there is archaeological evidence showing that the sites that are now considered historical milking grounds were the sites that were actually used by the Sami. And also pollen records show this transition from this uniform shrub tundra into a mosaic of shrub tundra and herb and graminoid tundra. So what then explains the why is the legacy so long term? So I introduced my co-worker Dagmar Egelkraut, who did her PhD thesis in these sites, and it was actually her conclusion that it's many mechanisms at the same time. And for example, she observed that there is more intense rodent herbivory on shrubs that are trying to invade into the historical milking grounds. So likely they are more exposed and they could be more nutrient rich because the soil has more mineral nitrogen still after one century of not being used. But you can read you can read the whole story in her publication. So I recommend you to look that up and take a more closer look there. And my part in this project was to observe what happens in the soil, and we did two different investigations. So we had a landscape level study where we had replicated study sites at two different vegetation types. We were comparing control and historical milking grounds, and also we were investigating this returning of vegetation into the same, similar to the control, using these transition zones where you could identify through this comparison of old and new aerial photographs. And that's my favorite tool. So taking soil cores and then analyzing activities in the laboratory, and also analyzing it in a way that with which activities in the soil are related to carbon cycling, which are related to phosphorus cycling, and which are related to nitrogen cycling. And what we found from the landscape level study are clear effects in the process rates. But what was interesting, that we actually didn't find any difference in the organic layer carbon stock or in the mineral layer carbon stock. So this informed us then that although all these plant and soil mediated processes had been different for several centuries, their effects on soil carbon sequestrations counteracted each other, so that you actually maintained a same rate of same quantity of carbon stored in the soil. And then in the transition zones, you could actually find then that when you were considering carbon cycling, these different vegetation patches in the transition zones were still very much the same as the historical milking grounds, but you actually were detecting changes in activities related to nitrogen and phosphorus cycling, so that these graminoid dominated patches resembled historical milking grounds, and the shrub dominated patches and heath dominated patches resembled the control. So we actually then demonstrated that there's a temporal discrepancy in how these different soil processes change in time when the vegetation is returning to the original state. So here are then conclusions from the study. So yes, reindeer herding exerts a legacy on tundra vegetation, and they have different plant and soil driven processes have different response times, and actually that this kind of research approach could provide a powerful tool for testing ecological predictions on the consequences of ecosystem change over the long term. And here are all this work is already published, so I recommend looking both of them. And finally, I introduce my co-workers in the project. So Dagmar Egelkraut did her PhD thesis in the sites, and Johan Olofsson was the PI of this project. And then we also owe all of our work to Kjell-Åke Aronsson in Aitemuseum in Jokkmokk in Sweden, who had conducted long-term archaeological archaeological research in the sites. So naturally, we couldn't have achieved our research goals without this co-work between archaeologists and plant and soil ecologists and awareness of the historical records on the land use. So this was then my talk, and I hope you enjoyed it, and I look forward to seeing you virtually.